So in this question, we need to write a method which removes duplicates from an unsorted list. Now here, let's say we have a linked list like this, so you can easily see that the value of 1 is repeated over here. This node over here is duplicate. So we need to write a method which takes linked list as a parameter and removes the duplicates from this linked list over here. Now how can we do that? Now in order to remove duplicates from the linked list, we need to be able to track the duplicates. So here we are going to use set for tracking them. So what we are going to do is we simply iterate through this linked list over here and adding each element to a set. Then when we discover a duplicate, we remove the element and continue to iterating. So let's look at the pseudocode of this algorithm that we are going to write over here. Now the first thing that we are going to do, we are going to create temporary node and assign first node value to it. Then we are going to add this node's value into the set. So in this case, in case of Java, we are going to create hash set. Then we are going to loop through these nodes over here. And this loop will continue until the current node's next value is null. Because in case of single linked list, the last node's next reference points to null. So we are going to loop through this linked list until we reach the end of this linked list over here. Then in each iteration, we are going to check that if the next node value in this hash set over here or not. If it is there, it means that this is duplicate value in our linked list. So we are going to delete the next node and continue to the next node. So otherwise, we are going to add this value to the hash and we'll continue our loop until we reach the end of this linked list over here. Now in our case, if we run the method for this linked list over here, so the first thing that it's going to do is going to add node 1's value to the hash set. Then in the next iteration, it's going to continue to the next node, and then it's going to add next node's value into the set over here, because next node's value is 2, and we are going to check that if 2 exists over here or not. So in the first stage, we see that we have only one element, it's not exist there, so we are going to add 2 over here. Now in the next stage, we are going to continue to the next node, which is node 3. Now in this case, we see that we have the value of 1 over here. Now when we reach the node 3, we are going to check that if this value is exist in our hash set or not. So in this case, we see that 1 is exist over here. So this means that this value is duplicate value. Now we have to delete this value from our linked list over here. So this means that we are going to delete node 3 from this linked list, and we are going to create a link from node 2 to node 4. So how can we delete node 3 from here? So we have learned that to delete node 3 from here, we just need to update the next reference of this node 2 to the physical location of node 4. Now in this case, the physical location of node 4 is 333, so we are going to set next reference of node 2 to 333. And with this, it's going to create a link from node 2 to node 4, and a link from node 2 to node 3 will be deleted. Now after deletion, we can easily see that this node over here is not referenced by any node in this case. So if you don't have any link to this node over here, it means that it's eligible for garbage collection. So garbage collector can come and delete this one from the memory. Now after deletion, we have a link from node 2 to node 4. So node 3, which has duplicate value, is deleted from the memory. Now we are going to continue to the last node. So in the last node, we are seeing that the value of last node is 3. We are going to check that if this exists in our set or not. So you see that it does not exist. So this means that it's not duplicate value. So we are going to add it to the set, and we are going to finish our algorithm over here. Now this is how remove duplicates methods work in our case. Now based on this algorithm that we explained over here, we are going to implement and create the method which removes duplicates from the linked list in practice. Now let's head over to Java and create our method over there. Now in our previous lecture, we have created a linked list class like this, and we have implemented 3 methods inside this linked list, and we have checked that if this is working in practice or not. Now here I'm going to create a new class in which we are going to write our method which is responsible for deleting duplicates from the linked list. So here I'm going to create a new file and name it questions.java. Now here I'm going to declare our class like this. So inside this class, I'm going to create our method. Now before going to create our method, let's import a Java library over here. So it's going to be util hash set, because as we mentioned before, we are going to use set in our method. So we are going to store the values when we are looping through the linked list. So here I'm going to declare our method like this. So our method will not return anything. So that's why I'm going to put void delete duplicates. So as a parameter, it's going to take linked list. So this linked list will be the type of this linked list class over here. So that's why I'm going to put linked list ll. So inside this method, the first thing that I'm going to do, I'm going to create set. So this set will be created based on this hash set that we imported over here. So that's why I'm going to declare it like this. Hash set integer will be new hash set. Then we are going to create two nodes over here. One will be the current node, in which we will have head value from the beginning, and the second will be previous node, which will be set to null. So I'm going to create node current, and it will take linked list head, and the second node will be node previous, and for now we are going to set it to null. Then we are going to loop through the linked list and check that if the value exists in this hash set or not. So if this exists, it means that this is duplicate value. Otherwise, we are continuing to adding to this hash set over here. So I'm going to write our loop like this. While current is not equal to null, this means that we still have nodes in our linked list. So we are going to continue our loop. So inside this loop, I'm going to create current value, which will be the type of integer, because when we are declaring our node over here, we have said that the value will be the integer. So that's why I'm going to put current value as integer, and I'm going to set current value to this car value over here. Then I'm going to check that if hash set that we created over here contains this value, so we are going to call contains method this value, then in this case it means that this is duplicate value. So we have to delete this node from the linked list. So how can we delete this node from the linked list? So if we set previous node's next reference to the next node, it means that we can successfully delete current node from the linked list. So that's why I'm going to call previous.next is equal to current nodes.next. So with this, we are deleting a link from previous node to the current node, and we are creating a link from previous node to the next node. So then we have to decrease the size of the linked list by 1 because we are deleting a node from the linked list. Then in the else condition, if this is not the case, if the value that we are in the current value, is not in the hash set that we are created over here, we are going to add it to hash set, and we are going to add the current value to hash set, and then we are going to set the previous node to the current node, because we are going to continue to the next node, so the previous node will hold the current node. Then in each iteration we have to go to the next node, so I'm going to set current to current.next. Now with this, we have successfully implemented our method over here. Now basically what we are doing over here is we are starting from the head and looping through this linked list over here, and in each time we are adding current node's value to the set that we created over here, and we are checking that if the current node's value is in this set over here, it means that we have already added this value to this set, so it means that this is duplicate value, so we have to delete it. So in case of single linked list, to delete current node from the linked list, we just need to delete the references that comes to this node over here. Now in this case, in case of single linked list, we have only one reference that comes to the current node, which comes from the previous node. So previous node's next reference points to this current node. So we have to update the previous node's next reference to point to the next node rather than current node. So with this line of code, we can easily do that and delete the current node from the linked list. Now, this is how our method looks like. Now let's see how this is working in practice. Now as you remember, we have created our linked list here in our previous lecture. Now in this case, we don't have any duplicate value. For example, instead of 4, if I insert 2 over here and run our code, you will see that in our linked list, we have duplicate value of 2. Now you see that our linked list looks like this. So here we have 2, 2. So this means that this 2 is duplicate over here. So if you call our method for this linked list over here, it has to delete these 2 from this linked list over here. Now let's call our method for this linked list over here. So what I'm going to do, after traversal, I'm going to create an instance of this question class that we created over here, questions. So it's going to be q equals new questions. Then I'm going to call delete duplicates method for this linked list that we created over here. So after doing so, I'm going to call traversal method one more time to see the differences after deletion. So if I run our code, you'll see that initially our linked list was like this. So here we have 2 duplicates. So the value of 2 is repeated over here. Now, after running this method over here, which deletes the duplicates, it becomes like this. So the second 2 removed from the linked list. So as you see, our method works the way that the question asks. So with this, we have completed our method successfully. Now the time and space complexity for this method will be O(n), because here, when we are writing this method, we are looping through all elements of linked list until we find the duplicates in our linked list. And we are inserting all elements to this set over here. So this means that it will take in memory O(n) space complexity. Now with this, we have come to the end of this lecture. So in this lecture, we have solved the question of remove the duplicates from the linked list. So hopefully everything is clear about this question. See you in the next question.